Wade and Wade Reacts.
We got a subscriber request to check out a video from the MetaNerd. He's a Gundam content creator. He also checks out Star Wars content. So if there's any other type of content outside of Gundam informational video that you want us to look at, let us know in the comments and let's get right into it.
What's up, MetaNerds? In taking the plunge into Gundam lore breakdowns, we'll include more episodes and specific lore points, individual ships, locations, that kind of stuff. Everything you need to really understand and appreciate this great, true sci-fi that simply has one of the best cool factors of all time.
True.
But in that effort, I found that I kept going further back and realizing that I need to attempt the perhaps foolish, but nonetheless fascinating lore and real-life inspiration behind the Minovsky particles. So this video will cover Trinov Y. Minovsky's complete life, what the particle is and what it does, and all the real-world stuff worked in along the way. Trinov Y. Minovsky was born in 1983, Universal Century 0015, near Chernobyl, Ukraine. At the age of 3, he witnessed the catastrophic Chernobyl disaster.
There has been a nuclear accident in the Soviet Union, and the Soviets have admitted that it happened. The Soviet version is this. One of the atomic reactors at the Chernobyl atomic power plant in the city of Kiev was damaged, and there is speculation in Moscow that people were injured and may have died.
Which may prove to be terrible foreshadowing of how the most complicated marvels of modern physics could fail terribly through a complex interaction of all too human behaviors. Not a physics problem causing Chernobyl per se, but everything from high-level political corruption to local laziness and accidents. In 1999, UC 31, his family relocated to America, where he began his education and initiated work on what he called Minovsky physics. At the time, his theories were considered highly speculative and unrealistic, with few understanding their potential. Despite this, his friend Ionesco informed him that Anaheim Electronics had agreed to fund his research, a development that thrilled Minovsky but left Ionesco less enthusiastic. This story parallels early work in quantum physics at the start of the 1900s. Let me keep on telling this story and I'll interject the real-world lore in a sec. Their primary focus was the development of a nuclear fusion reactor, and in the 40s, work began on the Minovsky-Ionesco reactor. Though Minovsky's work faced harsh criticism at a scientific conference in UC40, it was concluded that the Minovsky particle had no connection to nuclear fusion reactors, and his thesis was dismissed. Ionesco argued that the particle had only conventional technological applications, and no evidence supported its existence as a unique phenomenon. The reactor, originally designed by Dr. T.Y. Minovsky during his time with the Earth Federation, was considered what's called black box technology. Its principles were poorly understood by the classical physics community, which in the Gundam universe, all of what we consider modern physics, including quantum physics, is at this point all called classical physics. Minovsky had proposed a grand unified theory aimed at bridging Albert Einstein's theory of relativity with quantum mechanics, but his work was dismissed by the mainstream physics community, who saw his hypothetical particle as a revival of the outdated ether concept. He was branded a fraud, and this rejection led to his exile from the scientific community in UC 45. Shortly after, he was approached by the Zabi family and moved to Side 3, where he founded the Minovsky Physics Society. Pause in the story here to point out the parallels to quantum and nuclear physics and Einstein in World War II. Specifically, as, spoiler alert, this tech is what powers all the sci-fi weapons of war in the Gundam universe. And I think this real-world physics history shows this idea that a whole new set of physics that we are unaware of, that can rapidly change so much tech, is actually very plausible and not just simple space magic. Obviously, the greatest tech jump in all human history is in the 1900s. In the very first year of that century, in the year 1900, Max Planck proposed that energy is not continuous, but quantized, meaning it is emitted or absorbed in discrete units, later called quanta. He introduced this famous equation, where E is energy, H is Planck's constant, and V is the frequency of radiation, and this marked the birth of quantum theory. In 1905, we get Einstein's theory of relativity, the famous equation that revealed that mass and energy are interchangeable. This provided the theoretical basis for understanding how an atom's nucleus could release enormous amounts of energy if split or fused. Remember, Minovsky was working on fusion power. Einstein's equation showed that even a tiny amount of mass could be converted into a tremendous amount of energy, as we've seen in the real world with nuclear fission.
Those neutrons bombard other uranium atoms, causing them to split and split still others. The result? A chain reaction. Over 1 billion atoms exploding within 2 seconds.
In 1916, Einstein introduced general relativity, which describes space and time as a flexible fabric, space-time, which is warped by mass and energy. Some critics argued that this sounded like a modern revival of the ether. as space-time seemed to behave like a medium influencing physical phenomena. In 1920, Einstein himself stated, quote, "We may say that space is endowed with physical qualities. In this sense, therefore, there exists an ether." But he clarified that this ether was not the same as the mechanical, substance-like ether of pre-relativity physics. And it's that same knee-jerk reaction from the scientist in Minovsky's life that had him dismissed for proposing a new ether theory. But that part we saw where Minovsky was horrified by how his breakthroughs could be used for war seems inspired by Einstein's relation to the atomic bomb. The timeline goes something like this. In 1939, physicists Leo Szilard and Eugene Wigner approached Einstein, seeking his help to alert the US government about the potential for Nazi Germany developing nuclear weapons. Together, Szilard and Einstein wrote a letter to President Franklin D. Roosevelt, warning that uranium could be used to create a powerful new weapon and urging the US to fund research into nuclear fission. This letter, known as the Einstein-Szilard letter, is often credited with sparking U.S. interest in nuclear weapons research and leading to the establishment of the Manhattan Project in 1942. And to tie this to the Japanese writers creating Gundam only a generation after the war, it is said that after the bombings of Hiroshima and Nagasaki in 1945, Einstein expressed deep regret about his indirect role in the bomb's creation. He famously said, quote, "Had I known that the Germans would not succeed in developing an atomic bomb, I would have done nothing." So Gundam is playing with the idea of great scientists being pulled from opposing governments and their work so quickly being rushed into an arms race.
Fat Man is a real weapon.
Picking up the Gundam narrative on Side 3 with increasing support from the zombie family and leaders of the future Principality of Zeon movement. The Minovsky ionosphore reactor was groundbreaking as it was the first clean nuclear reactor, producing zero neutron radiation. The reaction it relied on was helium-3 plus hydrogen-1 react to form helium-4 and a proton, releasing 18.35 mega-electron volts of electricity. And so key to that process is helium-3, a rare isotope of helium with 2 protons and 1 neutron fused with deuterium, or heavy hydrogen, to create stable helium-4 in a single proton. The positively charged proton could easily be contained using magnetic fields, eliminating neutron radiation. But the major challenge was the scarcity of helium-3. On Earth, it is only found in small amounts, primarily in depleted uranium mines. The solution to this problem was the development of the Jupiter Energy Fleet. These fleets were tasked with traveling to Jupiter, which would harvest the rich supply of helium-3 in its atmosphere, and transport it all the way back to Earth to fuel the reactors. In real-world physics, helium-3 deuterium fusion would still produce some neutrons due to deuterium-deuterium side reactions, and helium-3 has been discovered on the Moon, but of course its abundance on Jupiter far surpasses the lunar deposits.
I would have liked that detail to have been added.
It's also just easier to collect. The Minovsky Physics Society encountered a mysterious electromagnetic wave effect in UC-65 while working on the Minovsky ionosphore reactor. After further investigation, they identified the cause: a new elementary particle generated by the helium-3 reaction on the reactor's inner wall. This particle, named the Minovsky particle, or M particle, possesses near-zero rest mass, with its mass increasing based on its potential or kinetic energy. It can carry either a positive or negative electrical charge, and when dispersed in open air or space, the charged Minovsky particles naturally align into a cubic lattice structure called an I field due to their mutual repulsion. The Minovsky particle has significant implications for combat and communications. When scattered in large quantities, the particles disrupt low-frequency electromagnetic radiation, including microwaves and radio waves, and interfere with unshielded electronic circuits due to their high electrical charge. This effect, known as the Minovsky effect, renders radar systems, long-range wireless
They really put some
communication,
thought into
and
the science
precision
in
electronics
Gundam.
nearly useless. It also scrambles infrared signals and create a fog effect with visible light.
I don't know who developed all that though. Was it Tomino or the other writers that came in?
That blocks or diffracts waves. This disruption is what led to such a rise in close-range combat, as it often made guided weapons like missiles impractical. While bulky shielding could counteract the M particle's effects on electric systems, such solutions were only practical for large ships and not for smaller precision weaponry. This ushered in a new era of warfare dominated by close combat weapons and mobile suits, such as those that were later developed by Zeon.
That was a cool fight right there.
Zeon researchers developed the Minovsky ultra-compact fusion reactor, the evolution of that Minovsky ionosphore reactor. Instead of relying on traditional magnetic fields, this advanced design uses an I field to confine and compress reactor fuel, catalyzing the helium-3 fusion reaction. The reactor recycled Minovsky particles produced during fusion to sustain the reaction itself, functioning similarly to a muon catalyzed fusion, which is studied in real-world physics. This design was 5 times smaller.
Yeah, they had to
than
have some
conventional
physicists come in and help
reactor,
them with the
making
science.
it compact enough to power mobile suits directly without external components. The ultra-compact reactor became the standard for mobile suits, providing an efficient, self-sustained power source. Minovsky further innovated with the fluid pulse system, which utilized Minovsky particles to enable precision altitude control, as well as power the suit's avionics, life support, and mechanical systems. This breakthrough provided mobile suits with functionally unlimited electricity to operate their joints, actuators, and onboard systems, making them highly maneuverable and versatile in combat. And then we see the development of the crucial ECAP, the energy capacitors. A mega-particle cannon, like those mounted on space warships, requires a substantial power source, a continuous supply of Minovsky particles, and a large enough condenser to compress those particles into megaparticles before firing. Due to these requirements, it initially seemed impossible to equip mobile suits with such weapons, but then we get the ECAP, which allowed for compact beam weaponry with significantly lower power and energy demands. It works by storing Minovsky particles in highly compressed, high-energy states, just below the threshold for fusing into megaparticles. When the weapon is fired, the mobile suit's generator, despite being far less powerful than warships, provides just enough energy to complete that process and creates megaparticles needed for the beam. The only catch is the mobile suits cannot recharge the ECAP themselves. Once the capacitor is depleted, the beam weapons become non-functional. Early beam
that's
rifles
trash.
had to be recharged.
I guess there has to be some type of drawback.
Entirely after their energy was drained. And the last tech I want to touch on is the Minovsky craft system. This takes us outside Trenov's life, but I just feel like it'll help us understand what we're seeing on screen in so many battles in different eras. The eye field, composed of charged particles, cannot penetrate conductive materials like metal, water, or the Earth's surface, and can be easily trapped with electromagnetic fields. At low altitudes, this property enables the creation of an eye field cushion between the underside of the vessel and the ground, creating a sort of buoyancy that counters gravity, a bed of particles, if you will. This principle is utilized by the development of the Minovsky craft system, which allowed spaceships and heavy ground vehicles to hover or sort of fly on Earth. During the One-Year War, the Principality of Xi'an was slow to adapt this technology. Only the MAX 03 Adzam and 3 prototype Apsilus mobile armors were equipped with the Minovsky craft systems, while in contrast, the Earth Federation quickly implemented the system on the Pegasus-class assault carriers.
They didn't play around. They wanted to make sure they had that advantage.
Within Earth's atmosphere and transition between space and the planet's surface. This system remained too large to be miniaturized for mobile suits until after UC-100. The first mobile suits equipped with such a device were the RF-104FF Penelope, introduced in Hathaway's Flash. The Penelope combined the RX-04 Odysseus Gundam with its fixed flight support unit. Another suit in the same series, the RX-105 G Gundam, also featured an MCS, but with the flight mechanism fully integrated into its structure. The Minovsky craft system eventually evolved into the Minovsky Drive, a more advanced propulsion system, and the first operational MD was installed on the Mother Vanguard, a ship of the Crossbone Vanguard fleet, where it was nicknamed the Sail of Light. This innovation allowed the ship to travel between Earth and Jupiter in just a few weeks, a journey that typically took months. After the Mother Vanguard's destruction, the SNRI, Strategic Naval Research Institute, were able to improve the drive, creating a smaller version that was installed on the F-99 Record Breaker mobile suits, which utilized the Wings of Light for propulsion. Unfortunately, all Record Breaker units, their parts, and related data were lost. Meanwhile, Anaheim Electronics salvaged the Minovsky drive from the wreckage of the Mother Vanguard and developed their own mobile suit featuring a Wings of Light system, later named Icarus by SNRI, after it survived atmospheric re-entry by using the wings as a shield. During the Zanskar War of the UC-150s, the Zanskar Empire deployed mobile suits on Earth equipped with beam rotors, devices that doubled as shields and rotary saws, which enabled long-range atmospheric flight. At the time, the Ligue Militaire introduced high-performance models like the V Gundam and V2 Gundam, which featured an improved version of the Minovsky craft system, the Minovsky flight system, which takes it all the way from a sort of particle brake or cushion projecting system, almost like a deceleration thruster you would use before impact, and now it's been so refined that it works for atmospheric flight in mobile suits. But back to the life of Drenov. Despite aligning with Side 3, Minovsky became disillusioned with the Zabi family's militaristic regime. In UC-70, Xeon researchers utilized Minovsky particles to disrupt electromagnetic waves, and developed a functional megaparticle cannon. In 71 is when we got those ultra-compact thermonuclear reactors based on Minovsky designs, which became the power source for the Principality's mobile suits. Although Minovsky received an award for his contributions, he publicly rejected it, tossing it aside in front of the entire Zabi family. A bold, disrespectful, and clear gesture of his discontent with the direction that they were taking his work. And in UC-72, he defected to the Earth Federation, where his expertise allowed the Federation forces to narrow the technological gap with Xeon. He would return back to Earth, going back to his hometown near Chernobyl, while he would also spend time at Side 6 and offer his research and theories to the Federation, hoping to balance the military power between the two factions. He later focused on the development of beam weaponry and contributed to the creation of the ECAP, that key technology for mobile suit beam weapons. Despite his efforts to prevent war by enabling a balance of power, his hopes were dashed when the one-year war broke out in UC-79. Some rumors suggest that Minovsky returned to studying the Grand Unified Theory later in life, attempting to unify photons and Minovsky particles. But there is no concrete evidence to confirm this claim, and other reports say that after the one-year war ended in UC-80, he was reportedly surrounded by mobile suits piloted by Xeon remnants, and may have been killed by the very technology he helped create. From a hope to deliver near endless, cheap, and clean energy via fusion reactions, and just a pure love of understanding nature, he would go to his death knowing that his breakthroughs had, for the foreseeable future, only made mankind more capable in killing each other. But to go back to the point of him trying to work on the Grand Unified Theory to figure out the interaction between photons and Minovsky particles, with one of the traits of Minovsky particles being that they have near zero mass, being so pliable, like a base particle able to take on positive or negative charges, it reminds me of the search for the Higgs boson, the so-called God particle. I'm old enough to remember when this was still a theory. It was first proposed in 1964 by Peter Higgs, and it wasn't discovered until July 4th, 2012. Via extensive research at the Large Hadron Collider.
I would like to add my congratulations to everybody involved in this tremendous achievement. For me, it's really an incredible thing that it happened in my lifetime. It's taken...
I wonder how that feels.
Good.
It's the final piece of the standard model of particle physics, a framework that describes the behavior of all known particles and forces except gravity. It is a quantum field throughout the entire universe through which everything else interacts. This field is crucial because it gives mass to elementary particles. Without it, particles like electrons and quarks would remain massless, preventing the formation of atoms, molecules, and ultimately the structure of the universe as we know it. The Higgs field is believed to have switched on just a fraction of a second after the Big Bang. To be precise, 10 to the negative 12 seconds, or 1/1,000,000th of a second, after the universe began. This moment is known as the electroweak symmetry breaking phase. During the very early universe, the Higgs field was in a high-energy state where all particles were massless, and the electromagnetic and weak nuclear forces were unified as a single force called the electroweak force. As the universe cooled and expanded, the Higgs field transitioned into its low-energy state, becoming active. This transition broke the symmetry of the electroweak force, separating it into the distinct electromagnetic and weak nuclear forces we observe today. Simultaneously, particles interacting with the Higgs field gained mass,
and watching Gundam at the same
structure.
time.
As you can imagine, there were several rival theories in those decades before the God particle was proven. And currently, zero-point energy is in this same space. It's technically more than just theoretical. By definition, fields that can enable other particles to gain mass, the fields themselves have energy. So the idea of zero point is that in any point in space-time, even if there are no particles, no mass, or heat of any kind, there is still energy at that point because the field goes through every point throughout all of existence. It follows from everything else we know in quantum physics, and there was even a well-documented experiment where two closely spaced metal plates in a vacuum experience an attractive force due to differences in zero-point energy between the space inside and outside the plates, dubbed the Casimir effect. Why it is often framed as theoretical is more for the fact that we currently have no way to harness it or turn it into a usable energy source. Theoretical calculations suggest that the energy density is immense, but extracting or converting it into work violates current understandings of thermodynamics. Even if zero-point energy could be tapped, it would likely require entirely new physics and technological breakthroughs far beyond what
Somebody will figure it out eventually.
And in that way, it sounds
In the
very
next
much
1,000
like
to
Minovsky
2,000
particles.
years.
And the jump we could
Could be
see if something
sooner.
like that was achieved could be as dramatic as what we see in the Gundam universe, if not more insane, honestly. So I hope you see
Possibly.
why I don't think
It's true.
Minovsky particles are just hand-wavy space magic for plot. I think like most things in Gundam, they're actually not that far off. Even the more heavily ridiculed psycho frames, I actually think are way more defensible than people think. In both, we just have people ironically hand-wavy, smug, and cynical saying, nah, it can never happen, because it goes against all our intuitions about the world. And I just think you could definitely say that for quantum physics too. And yet we use it every day in real-world tech, in the very device you're listening to me on right now.
Once again, shout out to the subscriber that recommended that we watch this video, because I never heard of this YouTuber before. And now I'm happy I did, because I'm gonna check out some more videos on my own time, because he also does Star Wars.
Okay.
And I like Star Wars a lot. So I want to see how he, brings up the science in the Star Wars videos. I try to explain it. And this video was cool because I didn't know what to expect when we first watched it, because we usually watch like Kakarot, Sloth Cakes, and a few others. But this guy had history lessons in there. He had science lessons in there. He also had Gundam lore. So it was like a lot of different things just packed into one.
Definitely. MetaNerd is a masterful YouTuber. This was a masterful breakdown. Like you said, he touched on the science that seems to be outlandish, far-fetched, or magical in nature, and he came up with ways that these types of particles, like the Minovsky particle, could actually be real in our reality. So man, it was cool to see him break that down scientifically. Now when I see certain things in the Gundam universe, I won't pass it off as unrealistic. I might think, dang, in the near future, we might be able to actually achieve something like that.
Yeah, and this video also answered a question I had in the beginning when we first got into Gundam. Like, what was the timeline? When did this take place? And somebody was trying to break it down. As a matter of fact, a few commenters was trying to break it down. But it sounds like the scientist Minovsky was born in the 1900s. That's what it seems like. And they said 1999 was UC 0031. So if that's the case, that means the Gundam universe is running like parallel to ours as far as the time. And if that's the case, where's our Minovsky scientist? Because I want a Gundam. Give me a mobile suit.
Yeah, I would definitely like a mobile suit, the civilian mobile suit now. I wouldn't want to be involved in the war. But like you said, since the UC timeline at that point was in the 1990s, it seemed like, right? Or the 1980s when Minovsky came around, if I'm not mistaken. I could have the date wrong. Where is the UC timeline in relation to our timeline in the series Unicorn? What year did Thunderbolt take place in?
You can do the math. It's like if 1999 was UC 31 or 0031, then you can, on the spare time, do the math.
That does it for our reaction to The Most Important Man in Gundam by MetaNerd. Don't forget to leave your thoughts in the comment section. Also, like, share, subscribe, and hit the notification bell so that you'll never miss a video from Wade and Wade Reacts.
And we're out of here.
Peace.